we present Temporal Saliency query network for efficient video recognition. Efficient video recognition is to classify videos into predefined classes using as few computers as possible. As a line of efficient video recognition methods, the temporal sampling-based method includes two stages in this typical pipeline. Firstly, we train a lightweight frame sampler to sample a small number of silent frames. For example, we use a scoring model to score all frames and select top key-scored frames. Then, we use an expensive recognizer to evoke recognition only on those sampled frames. Previous methods typically measure class-agnostic saliency scores. However, this leads to falsely high scores of the non-silent frames, which belongs to the other classes than ground truth class. We propose to measure class-specific saliency scores and select silent frames corresponding to the most probable class of the video. To this end, we propose a novel temporal saliency querying mechanism, which formulates the frame sampling process as a query response task. Each category is cast as a specific query, and the most silent frames corresponding to it are returned as the responses. After feature embedding, video features and query embeddings are passed into TSQ layer to compute cross-attention rates, and a class-specific classifier is followed to obtain a cross-video class prediction. During testing, we take out the cross-attention rates and the crossly predicted class, and select the frames with the highest scores of the corresponding class. The basic structure of TSQ layer consists of standard cross-attention layer and FFN. It outputs the network output and cross-attention rates. The class-specific classifier is applied to obtain a cross-video class prediction. The whole framework of our TSQ net is divided into two branches. The upper branch is based on visual modality, and the lower branch is based on the text modality. We fuse the saliency scores of the two modalities during testing. For the visual modality, the queries are initialized with the class prototypes of the visual features. For text modality, the queries are initialized with the bird embeddings of the class names. During training, we swap the attention weights of two branches to perform interaction between two modalities. TSQ-net achieves the best accuracy-efficiency trade-off among the recent competitive methods on ActivityNet, ECCV'22, and the mini-kinetics dataset. We present extensive ablation studies to validate the effectiveness of our design of the class-specific sampler, multimodal combination, and initializations. It can be observed that with the proposed TSQ mechanism, our approach can sample much more indicative silent frames. That's all. Thank you.